Hi. Today we're going to look at antiderivatives that require some algebra and trig to simplify before we can find the antiderivative. And a little bit of notational change. But let's start in an example here. Suppose f of x is equal to 6 cube root of x minus 4 square root of x squared divided by 4 square root of x cubed, divided by 5 times the 5th root of x to the 8th. And this is problem 1C in the worked out examples. As I had to do when we talked about derivatives of something like this, again, I will have to find the antiderivative. I need to simplify this algebraically. So I'm going to do exactly the same algebra at first. This is 6 x to the 1/3 minus 4 x to the 3/2 divided by 5 x to the 8/5, or 6x to the 1/3 over 5x to the 8/5 minus 4x to the 3/2 over 5x to the 8/5, which then becomes, using my rules of exponents, 6/5 x to the, I get 5/15 minus 24/15 is negative 19/15 minus 4/5 x to the, I get 15/10 minus 16/10, which is negative 1/10. This is still the original function. I have not found the antiderivative yet. We can now, however, this is basic, we can now find the antiderivative using my reverse power rules. This becomes 6/5. Add 1, I get x to the negative 4/15. Reciprocal, negative 15 over 4, minus 4/5. Add 1, I get x to the 9/10, reciprocal 10/9, put the plus c. And then we can simplify this. Before I simplify it, I'm going to reduce. See, 5 goes into 5 once, negative 15, negative 3. 2 goes into 4 twice, 6 3 times, and so therefore I end up with negative 9/2 x to the negative 4/15 minus, and then this will simplify as 8/9 x to the 9/10 plus c. This is my antiderivative. Again, I had to do some algebra first before I could take the antiderivative. Now, let me introduce new notation. Rather than dealing with this notation and saying that, given an f of x, we can find the antiderivative, capital F of x. Let's look at the bigger picture. So, before, we started off with some function, little f of x. We took the derivative, and I got f prime of x. We can take the derivative of that and get f double prime, etc., however many times we want to, assuming that these derivatives exist. We now introduce giving f of x, we can find its antiderivative, capital F. Well, let's in general say that anytime I go this direction, we're talking about a derivative. So think of this as a ladder, and when I go this way down the ladder, we're talking about the derivative. When I go up the ladder, I'm talking about the antiderivative. And the notation that we're going to use is that the antiderivative of f of x is going to be written in this. This is called an integral form. And this is equal to capital F of x plus c. This notation means the antiderivative of little f of x. And so based on this, let me erase this part of it. Based on this, I could have said the antiderivative of 6 cube root of x minus 4 square root of x cubed over 5 fifth roots of x to the 8th. Don't worry about the dx. We'll just throw that in at the moment. It has a meaning, but don't worry about it for right now. This is equal to, based on what we found, negative 9 halves x to the negative 4 fifteenths minus 8 ninths x to the 9 tenths plus c. So rather than writing little f of x and capital F of x, this means find the antiderivative of that function. So it's a little easier notationally. So let's look at a couple more examples here using that notation just because of simplicity's sake. Suppose I want the antiderivative of sinh of x plus cosh of x divided by e to the x. There is no rule for antiderivatives of quotients. We have to simplify this algebraically. And in order to do that, I need to remember what, or look up what the what sinh and cosh are. Sinh, remember, was e to the x minus e to the negative x over 2. Cosh, e to the x plus e to the negative x over 2. And all of that was divided by e to the x. And so, let's now simplify this algebraically. Notice, in the numerator, I already have a common denominator, so we could go ahead and combine these. And in this case, notice that the e to the negative x's cancel each other out. And now I have a fraction divided by e to the x. Think of this multiplied by the reciprocal. And so this ends up being 2e to the x over 2e to the x, or just the integral of 1 dx. Very, very, very simple. Now, this antiderivative is x plus c. The algebra makes everything just about go away. My next couple examples will involve some trig. Suppose I have the antiderivative of sine of 2x divided by sine cubed of x dx. For this, we need to remember what the identity for sine 2x is. This is 2 sine x cosine of x. And then this can reduce, and so I'm left with 2 cosine of x over sine squared of x dx. Now the 2, remember when we take the antiderivative, the number just stays, and so I don't really care about that. I can just leave that on the outside. But what to do with the cosine of x over sine squared of x? This is where, let me actually bring the 2 out. I can write this as cosine of x over sine of x times 1 over sine of x, which then gives me 2 times the antiderivative of cotangent of x cosecant of x. Hopefully you recognize this is a basic form, a basic derivative that we had. This is the derivative of the negative of cosecant of x. And so my final result, negative 2 cosecant of x plus c. And my last example, we get the integral of, or the antiderivative of, sine cubed of x over cosine squared of x dx. Now to do this one, we need to be a little bit tricky in a way. I'm going to write this as sine squared of x times sine of x over cosine squared of x. The reason being, I have, again, another trig identity. Remember, sine squared of x plus cosine squared of x is equal to 1, so therefore cosine squared of x is 1 minus sine squared of x. Or, that's not what I want. Let's try this one. Sine squared of x is equal to 1 minus cosine squared of x. This is the one I need. And so I will write this as 1 minus cosine squared of x times sine of x over cosine squared of x. Which then gives me, I can now distribute and break this apart. I get sine of x over cosine squared of x. I need to erase this so I have room. Minus sine of x cosine squared of x over cosine squared of x. The second one here is pretty simple. The second part of this is just sine of x. The first one, hopefully you recognize, is very similar to what I did previously. Sine of x divided by cosine of x is tangent of x. 1 over cosine of x is secant of x. And so this simplifies down as tangent of x times secant of x minus sine of x. The antiderivative then of this is secant of x. The antiderivative of the negative of sine of x is cosine of x, and then plus c.